Hi, my name is Adonis Leal, and I'm here again to speak about another paper. Now, I will discuss on the automated low-cost setup for optical and e-field records of lightning, a collaborative work of two labs at Federal University of Pará. For more details, you can read the full paper available in this link, and that's copied in the description of this video as well. Okay, lightning discharges can be detected by their electromagnetic field radiation, for example, lightning electric fields here, and they can be seen by the radiation that they produce in the visible spectrum, like lightning image here. So in order to have a complete picture of this natural phenomena, scientists around the world combining different measurements in their analysis and investigations. More recently, light records in the visible spectrum have been used to study different lightning processes, including the triggering mechanisms of upward lightning, attachment process, performance of lightning location systems, and lightning images can be used for the reconstruction of the lightning channel in 3 dimensions using different techniques such as stereo video or medial elevation angle difference based on the azimuth intersection. However, many of the instrumentation used in the works mentioned before are out of budget of many lightning research groups around the world, mainly in developed countries. So in order to increase the access of lightning images and lightning electric field measurements to lightning research groups, we proposed an automated and low-cost setup for record optical images, however, not in high speed and electric fields of lightning events at the same time. Now I show the block diagram of the proposed setup that's composed by an electric field antenna that can be a flat plate or white antenna, an integrated circuit, a triggering circuit, a DSS, digital storage system, a microcontroller, Bluetooth shooter, a smartphone with Lightning app camera, a GPS module, and a SD card module. Well, if an electric field pass a certain threshold, the trigger circuit sends a pulse to the DSS and to the microcontroller. When the microcontroller receives this pulse from the trigger circuit, it sends another pulse to the Bluetooth shooter, and then we start to get the lightning image. And at the same time, we have the GPS timestamp. Okay, now let's move for the preliminary tests at the high and extra high voltage laboratory. In the laboratory, we used a 25 centimeters long wipe antenna in order to record the electric field. We used the DSS, a Pixscope 3000, a laptop, and the smartphone that we used was a Galaxy S9. In order to produce the long spark, we use a Marx generator, and the long spark had 1.3 meters long. All the instrumentation was about 17 meters from the long spark. Here we have the arrangement that we used in the high voltage lab in order to produce the long spark, and here the the preliminary tests. Well, in the first test, we could not see the long spark channel because the image was too bright. And in order to overcome this issue, we used X-ray film in front of the smartphone lens to reduce the exposure of the smartphone lens. And in the second test, we could see the long spark channel here. And we have here in the bottom of this image, the electric field that we record with the wipe antenna and all the instrumentation. And here in D, we have the records of the half-lay instrumentation. Now let's move to the results of a natural cloud-to-ground lighting. So on April 2 of 2020, we recorded image and E-fields of a natural cloud-to-ground flash containing 80 return strokes. You can see here the electric field records, and here a few images that we could record that we can see the lighting channel here. We also could see intra-cloud branches in the image that could be related to the electric field signatures of intra-cloud. Now let's move to discussion. So in the Lightning Observatory in Gainesville, the overall cost of such type of instrumentation is about 75,000 US dollars, considering a Fentel high-speed camera, LaCroix oscilloscope, fiber optic links, and other minor instrumentation. In our setup, the costs can vary from about $1,200 and $3,500. Depends on the DSS that we use it for record the electric fields. In summary, the setup was tested using long sparks at the high voltage lab, and we successfully recorded for the first time in the Brazilian Amazon region lighting images and lighting E-fields at the same time that can be used for future research and analysis for lightning occurrence over the Amazon region. The authors would like to thank ProPest for the PBIC scholarship, and a special thanks go to Dr. Rakov, coordinator of LOG, for providing information on log instrumentation. Thank you for your attention, and for more details, you can read the full paper with more images, and see you in the next presentation. Bye.